Hello everyone, and welcome back to another adventure in electronics, robotics, and communication systems. This is ChatGPT Can It Code Part 2, and I think you know what we're here for. 1. Challenge the AI to generate code. 2. Inspect that code for anything unusual. And 3. Deploy that code to hardware. Today I'm covering a newcomer to the unboxing series. We have the OSEP Uno R4 Plus board, which is Arduino compatible, and its corresponding LCD and keypad board. Although in the Arduino ecosystem, we would call this board a shield. I am going to warm up the system with a couple of basic questions. I generally find that if I ask about the pinout, and ChatGPT doesn't get the pinout correct, the source code it will produce is not going to be reliable. In fact, it might be unreliable even if it gets the pinout right. So before deploying it to your application or trusting whatever it says, verify everything it says. This has security implications that I'll go into later, and if you want to see that one, be sure to subscribe to this channel, and keep in mind this is an ongoing series. Most Arduinos operate at either 5 volts or 3.3, and getting this wrong can permanently damage your own hardware. For today, both of these boards operate at 5 volts, and they were literally designed for each other by the OSEP company. The Liquid Crystal Display, or LCD, is a 16:2 character display, and if I'm not mistaken, it supports the Romanized alphabet and Japanese katakana. It does not support Unicode, so if you need more than the basic 256 characters, you're going to need a different type of display. The advantage here is its driver, which is compatible with the classic Hitachi HD44780. That's a mouthful, but it's a long way to say that this display has been well known since the 1990s, and there's a good chance its Arduino driver was part of ChatGPT's training data. Let's start to test that now by asking the model to create a new program, and this program should create a breathing pattern on the onboard LED. Breathing is another way of saying that we are dimming the LED, cycling it from minimum to maximum brightness, and normally this is done through pulse width modulation, or PWM. If I'm not mistaken, there's already an example like this, but this is meant to be easy, and if we can't control the Uno baseboard, there's no way we're controlling the LCD. The second test is going to be more difficult. I am asking it to print the message "Hello World" on the LCD, but I'm not going to specify where on the display that should happen, or even whether the cursor should be visible. For good measure, I'm also going to request that the LED blink, and if you have one of these displays for yourself, the HD44780 will traditionally display a line of filled characters on the top row, and the second row is going to be completely blank. This is something the display is going to do as soon as it's powered on, and this operation is completely internal. You can think of it as a test pattern, and even if my code fails, we will at least know that something is working. The third and final challenge is to modify this program. I want it to read the state of the tactile switches on the top board, and if any switch other than reset is pressed, the program needs to display the message "pressed" on the LCD. Otherwise, there should be no changes. Before we go on to the test, I'd like to thank everybody who supported this blog. This is a small operation, but it's growing, and this also means your feedback is going to have a large influence. This week I am posting my ChatGPT questions, including random ones, to Patreon and buymeacoffee.com, and like usual, you can get these videos early on the decentralized platforms Minds.com and Odyssey.com video. Thank you once again, and with that, let's see how we did. The first test of generating that breathing pattern didn't exactly go well, but the LED is still blinking. This is what it did after uploading twice. So either this is the original programming, or I'll have to classify this as a failure. It is not often that I use the analog out function, because generally if I want this I'll use a digital to analog converter, or I will set up the PWM using the registers, because I normally like to use face-corrected PWM instead of the default setting. For the second test I requested "Hello World," and this time blinking the LED is acceptable. At first it behaved just like it did in the previous test, so I decreased the delay between blinks, re-uploaded, and was able to verify that the code had uploaded. The LCD only displayed its test pattern. At this point I remembered seeing the blue variable resistor on the board. Sometimes the LCD requires fine-tuning, and if the contrast is set too high, you are only going to see filled pixels. I retrieved an adjustment tool from my toolkit and adjusted the contrast up and down. It did not fix the problem. While thinking about the code, I noticed there wasn't a specific header file called out for the display, which meant that there are no definitions to get the pins right. At a minimum, this style of LCD requires 2 control lines and 4 data lines. In this case, every pin definition was incorrect. Fixing this single line of code also fixed the problem. In summary, just watch out because connecting 2 outputs together, even by accident, can damage the microcontroller. With the third and final test, I was going to be a little bit more careful, so I checked the pin assignments against the drawing from the supplier, and I discovered that buttons 1 and 2 had been incorrectly assigned. ChatGPT had treated these 2 buttons as if they were regular tactile switches. Normally, a push button like this will pull the line either down to ground or up towards the supply voltage. It's a simple on-off operation. The display board does this differently. Each tactile switch is part of a voltage dividing structure. Assuming that only one key is pressed at a time, this resistor network is going to generate a slightly different voltage depending on the key pressed, and we can read that voltage using one of the analog inputs. OSEP likely did that so that the entire key array can be read using only a single pin. The only reason I caught this was because of prior experience, and being on my guard after that second test failed. It is a reminder that, at least in this iteration, this is just a large language model, and the chatbot does not know what it's saying. Regarding IoT security, I think you should be on guard there as well, just because of the security implications. I've got more to say about that, but I think this is a topic for another day. If you have a request for another board, let me know in the comments and I'll see what I can do. This is an ongoing project, so share your feedback, stay posted for part 3, and as always, have a great day.